In this example, we want to quickly go through two examples of difference of cubes formula. You'll see here that when you have your difference of cubes formula, just to remind you, the difference of cubes formula is as follows. So taking a look at your difference of cubes formula, we can see that what you need to happen is you need to have an expression to the power of 3 minus another expression to the power of 3. They do not just have to be one variable, it could be multiple variables and multiple terms as well. So in this example here, we want to be able to express this as a base to the power of 3 minus another base to the power of 3. We see that this exponent of 3 is being applied to the a, but is not being applied to the 125. So what I can do here is I can make the observation that 5 cubed is 125, in which case I can rewrite 125 times a to the power of 3 as 5a, the whole thing to the power of 3, minus b cubed. So now we have a difference of cubes, in which case this takes the place of my x, and this takes the place of my y. So we have x minus y, and you can see that here, x minus y. Then you have your first expression squared. If I square 5a, you can see I get 25a squared. Then we have plus the product of your x and y values. So in this case here, this is my x and this is my y, so it'll be plus 5ab. And lastly, plus y squared. So in this case here, my y value represented by b, so it's going to be plus b squared. So now our expression here is now fully factored. In the next example here, we want to be able to apply our difference of cubes formula. You'll notice here I have a 1. I can raise that to the power of 3, and now we've expressed that as an expression to the power of 3. I don't have that here though, but what I can do is, remembering my exponent laws, I can rewrite this as x squared, the entire expression to the power of 3 minus 1 cubed. And now we have our difference of cubes formula. So again, just to remind you, your difference of cubes formula is as follows. So this is my x and this is my y. So this becomes x minus y times x squared. So my x value here, you take your first term and you square it, in which case that'll give me x to the power of 4, plus the product of my x and y placeholders, which will be plus 1 times x squared, which is just x squared, plus the square of my y placeholder, which is just 1. Now you can see here we can continue this. I can go ahead and apply difference of squares here, giving us x minus 1 times x plus 1, and then we have our degree 4 polynomial here. Now the question here remains is, can we factor this further? Well, you'll notice here that if you look at x to the power of 4 plus x squared plus 1, you'll see this is a perfect square here. I can write that as x squared. This is a perfect square here. I can write that as a plus 1. If I were to expand this whole thing out here, you would get x to the power of 4 plus 2x squared plus 1. And now we've talked about this in a previous lesson. I'll link that in the top right-hand corner. This is an incomplete square. So what that means is I do not have equality between these two yet. However, if I subtract off an x squared, you'll notice when I expand this out, you're going to get x to the power of 4 plus 2x squared plus 1 minus x squared, which will simplify to become x to the power of 4 plus x squared plus 1, which is exactly what we have here. So therefore, I can rewrite this expression here as follows below, giving us the following. And you'll notice here, now we forced a difference of squares here. So I can go ahead and apply my difference of squares formula, giving us x squared plus 1 minus x times x squared plus 1 plus x. So reorganizing this just in descending order by your exponents, I end up getting x squared minus x plus 1 times x squared plus x plus 1. And now we are in fact fully factored here. Okay, so this is an example of your difference of cubes formula. I chose to force the difference of cubes right away and go through the factoring process. We needed to do an incomplete square over here to factor this fully, and we have our final answer. Let's take a look at this exact same problem, but instead of starting off with a difference of cubes, let's start off with a difference of squares. So now looking at this expression here, if I want to express this as a difference of squares, I'm going to write this as x cubed to the power of 2 minus 1 squared. And you'll see by doing that, this becomes x cubed minus 1 times x cubed plus 1. Now I have a difference of cubes and I have a sum of cubes formula. To remind you of these two formulas, we have the following. So applying these formulas here, we get the following. We get x minus 1 times x squared plus x plus 1. and then we have x plus 1 times x squared minus x plus 1. And you can see here by approaching this a little bit differently, the solution was a little cleaner. But again, you don't know which way is going to always end with the cleanest solution. So the incomplete square process was important. Had we started off that question with a difference of squares, it would have flowed a little cleaner, a little quicker, and we would have gotten our fully factored expression. Thank you.